Welcome. In this video I'm going to show you how you can perform a C-square test, which is an improvement on the Brunner-Munzel test using Microsoft Excel. In a separate video I show you actually how you can use my own add-in, which simply then has a function for this, but in this video I won't be using any add-ins at all. The video will focus on how to obtain the results for this test, not so much if you should be using the test and how to interpret the results of it. My data is in columns A and B, and I've also actually listed the ordinal data in the categories in the proper order and gave them each a number to it and the two categories that I'm going to be using. The first thing I'm going to be using is actually use those scores rather than the text. So that's being done in column C. It's simply checking if both of these are not empty, then it's going to look it up in this table and return to me the second one. As you might notice, my version of Excel is using a semicolon to separate parameters. Yours might be using a comma. I put the dollar signs in here because that will fix actually this little range, this little table. So I can simply copy paste it down and then simply have all the scores. So too little has a score of 2 and too little indeed has a score of 2. Then we need some ranks. So the mid ranks, the minimum ranks and the max pooled ranks. So the minimum ranks can be done by just using the EQ version, which is equivalent. So that will actually give the lowest if there's a tie. So there are multiple who had actually a score of 2. So it's apparently the third one that's actually the first that had a score of 2. So this is the minimum ranking. You can also use average ranking, so if more than one then has the same score, it will actually use the average of what the ranks would be. Last but not least is then of course using the maximum, which is actually simply twice that average minus 1 time the minimum. Once we have those, we can actually go to the next step, which is determining the placement values, and that's being done in columns oh no, we first need to separate the two. That's the next step, sorry. So we simply split the scores into the two different categories, and then we actually repeat what we've done over here, but then only using the scores from that particular category. So it's the exact same thing for the males and the females, the maximum ranks for the male and the females, and we actually don't need the mid ones. What we do need is also the so-called placement values, which is the difference between this one and the average one. So we do need the average one, sorry. We only need it for the second category, that was it. And only the first category we also need the regular mid-ranks from, because we need to calculate that placement value, which is the difference between the within mid-rank and the pooled mid-rank. All right, so then we have basically all the ranks that we need. That brings us then to determining the sum of the square deviations. So that's simply taking the placement value minus the corresponding mean and square the result for each of them. So that's where the function def squared comes in. That's the default function that comes with Excel, and we can do that for both categories. We also need all of the counts, so in this case 34 for the males, and simply count the last two columns. Don't count the first two because, for example, let's see, do we have a good example? Yeah, here somebody is female but didn't do a score, so they shouldn't be counted in our sample sizes. All right, once we have that, it's a matter of determining some of the means of the minimum of the ranks of category 2, the mid ranks and the maximum ones. And once we have all that, we can then just complete this formula. It looks scary, but we have all of these values, so we can just simply pick them up and refer to the appropriate cell for that. The same goes for this theta or theta. We have everything we need for that, and we can just simply fill out the formula. The denominator, as you can see for this big formula, is this. It's the sample size of the first category multiplied by itself minus 1, and then multiply that with the same thing for the second one. So that's we have all of that, so it shouldn't be too difficult. Then we determine the variance with this scary looking formula, but again we have all of these, so it's just a matter of filling out that formula and referring to the appropriate cells. Which finally gives us the test statistic, which in this case is this one, and that's just a matter of filling out again the appropriate cell references, and we have ourselves our c-square value. There's actually a distributed chi-square with a chi-square distribution, so we can use the chi-square distribution, the right tail, and the number of degrees of freedom is simply 1. And then we finally have the p-value, which is probably most interesting. If that's below 0.05, that's the usual threshold, we would speak of a significant result and claim that the two categories think significantly different about, in this case, mixed number of activities. You can do all of this also by using a contingency table, so that's an alternative method but should give the same result. So here I just create a cross table using count ifs. So for example, there were 15 male students who thought it was exactly enough. For the max ranks, which is actually then just the cumulative frequencies, which is the same as the regular frequencies for the first row, but then you actually just keep on adding them up. So for the first column, sorry, and then you just keep on adding them up. So 1 plus 2 gives me that 3, plus 15 gives me the 18, etc. The minimum ranks are the maximum ranks minus the original count. So we simply take this one minus that one and we add 1. So as you can see, that gives you then the minimum rank. The mid rank is then simply the average of those two, and then the placement scores is again the difference, because I've also been doing the total, so that's then the mid ranks. Once we have all of that, we can calculate those means. We can use a sum product function for that. That will simply multiply the original counts with the corresponding rank and then divide by the sample size. Once we have those, we can determine again that variance. So what we do first is we calculate the squared difference between the original value and the average. And once we have all of them, we can simply do a sum product again to get that sum of squared. Then we can determine that tau again, which is now again just filling out the formula, so setting the appropriate references, getting theta again, the denominator, the variance, and then finally the c-square value and the corresponding p-value, which as you can see is again the same. Alright, I hope this video was helpful and thank you for watching.